everyone, my name is Fan Zhang. I'm from University of Florida. Thanks for being here. Today I'll share our work on a multi-agent system which personalized support in K-12 math. The system combines a tutor agent which can talk to students, a real-time detector which can raise language signals to infer cognitive and emotional states, and a holistic analyzer which combines surveys with dialogue history. I will walk through the motivation, our study and models, and the key findings, and where we are heading next. So, first, why multi-agent system for education? Because learning needs different kinds of help at different times. One agent can converse with a student, another can watch for overload or frustration from the language cue, and a third can integrate longer-term trends. This division of labor makes the whole system more responsive. Prior work shows multi-agent system can coordinate complex tasks. Here we apply the idea to adaptive instruction too, so each student gets the right help at the right moment. So why we should assess cognitive load in real time? Cognitive load matters because working memory is limited. If a prompt is too dense or the pacing is too fast, students stop learning even when they keep clicking. Traditional measures like NASA TLX or post-task surveys are helpful but retrospective and intrusive. Our end goal is to use the student's language during dialogue as a real-time, low-friction signal of intrinsic, extraneous, and germane load. That way, the tutor can adjust during the activity, not after it. Our contribution is a next generation large language model driven multi-agent system which can learn from student and tutor teaching dialogues. It can detect cognitive and emotional states in real time from the conversation and use those signals to adapt the tutor reply. We also ask two research questions. Research question 1: Can, la can language model detect the relevant student states accurately? And research question 2: After we feed those detections to the agent, if it could generate more adaptive, supportive responses. Here is a experiment setting. We ran the study in IELTS Math. Is a learning by teaching setup where students explain math to a tutor agent. We worked with 155 elementary and middle school students at IRB approval. Over 10 days, we logged about 1,440 dialogue segments. We also collected pre and post questionnaire for AI and math attitudes and post measure of I, IC, ICL, ECL and GCL. This gave us a rich pairing of language data and psychological measures. To train the detector, we mapped survey items to our contracts. AI and math attitudes plus ICL, ECL, and GCL. The table right shows detailed questionnaire items. There are 6 AI relevant questions and 8 math relevant questions and 6 cognitive load questions. So here is the workflow. Students teach the tutor agent. We capture the dialogue and the relevant time stamps. We pre-process the text, create chain and validation faults, and train, train several detectors from classic TF-IDF models to modern neural and large language model based models. We trained the detector with 5-fold cross-validation and tracked subset accuracy, micro recall, and micro F1 and Hamming loss. Then we ran offline emulation of real-time detection to see if right after each student turn, the system could produce a fast, reliable state estimate to guess the next tutor move. Um, the multi-agent architecture has 3 agents. The learning by teaching large language tutor which could chat with the students. The real-time detector which could predict states pattern and holistic analyzer which looks across the session using pre-post questionnaires and profiles. Uh, it will the real-time detector will generate a student state and give feedback to the large language model agent so that the tutor could adapt its next response based on the student cognitive load and student emotional state. Then is the results. Here is this table is the result for psychological and cognitive load measurement task. We can see different models performance in this table. So on research question 1, the Llama 3.21 billion model performed best overall with a high micro recall and F1 and a low Hamming loss, meaning it captures multiple stimuli multiple labels well. However, classical baseline were not noticeable weaker, which suggests the richer language model helps pick up lost signal of overload, confusion, or confidence. Latency in our offline emulation stayed under about a tenth of a second per segment, which is fast enough to drive 10-level conversation. This table summarizes how the tutor's next turn changes with real-time signals. The rows list 2 student states, high cognitive load and low confidence, and the column 1 compare a generic tutor vs adaptive tutor. Read it left to right. The left column shows the default one-size-fits-all replay, and the right column shows how the replay is adjusted once the detector flags a specific need. For high cognitive load, the adaptive tutor simplifies language, breaks steps into small chunks, and adds a quick worked example to reduce clutter and cognitive burden. And for low confidence, the adaptive tutor warms the tone, acknowledges partial understanding, and offers one concrete next action to rebuild the momentum. We also list several future works. First, we will move from observational analysis to A/B test or classroom RCTs to verify effects on learning and well-being. In parallel, we will extend beyond mathematics and beyond a single region or school system to test robustness across subjects, grades, and demographics. Also, we will transform from offline emulation to live classroom deployment with streamed inference, reliability monitoring, and failure mode logging while running continuous audits for privacy fairness to ensure trustworthy and instruction aligned behavior. Thank you everyone. Any questions?